Design of machine elements to module 1 18 scheme. So first module or module 2 for 17 scheme. So this is springs, design of springs. So for 18 scheme is module 1 and for 17 scheme it's module 2, design of springs. So the content is same for both 18 scheme and 17 scheme. So introduction of design of springs. A spring is defined as elastic body whose function is to distort when loaded and to recover its rotational shape when the load is removed. The important application of the springs are as follows: to apply forces in brakes, clutches, spring loaded walls. Second, to measure the forces in spring balances, to store energy in watch springs, to absorb shock and vibrations as in car springs and railway buffers, to control the motion by maintaining contact between two elements as in cams and followers. Types of springs. First one, helical spring. Helical springs are made up of wire coiled in the form of helix and is primarily intended for compressive or tensile load. Helical springs have the following advantages. These are easy for manufacture. These are available in wide range. Third one, these are reliable. Fourth, these are constant. These have constant spring rate. Fifth, the performance can be predicted more accurately. Sixth, the characteristics can be varied by changing the dimensions. Second types of springs are conical or involute springs. Third one is torsion springs. Fourth one are laminated or leaf springs. Fifth one are disc or bevel springs. Sixth one are special purpose springs. Terms used in spring compression springs. Solid length. First one, solid length. When the compression spring is compressed till the coils come in together, then the spring is said to be solid. The length is I dash. Solid length equals to I dash D. I dash is the total number of turns and D is the diameter of spring wire. Second one, free length. The free length of the compression spring is the length of the spring in free or unloaded condition. Free length is LO is greater or equal should be equal to I plus N into D plus Y plus E, where A is the clearance, I is the number of active coils or turns, Y is the maximum deflection. Third one, spring index. The spring index is defined as the ratio of mean diameter to the coil of the diameter of wire. So spring index C is capital D upon small d, where D is capital D is the mean coil diameter. Fourth one, spring rate. Spring rate is defined as the load required per unit deflection of the spring. So spring rate F0 is F by Y, where Y is axial deflection. Fifth one is pitch. The pitch of the coil is defined as the axial distance between the adjacent coils in uncompressed state. So pitch P is LO minus 2D upon I. For square and round ends, I equals I is number of turns, LO is free length.